Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Okay. Uh, so okay, let's check out the odd odd even thing. So a function. So first thing is that can a function be both odd or even? F of minus x is equals to f of x is the criteria for even, and f of minus x is equals to a minus of fx. This is the criteria for odd. Okay. Now a function cannot be both odd or even unless f of x is 0. So if you equate this, you'll find that f of x is 0. So it's either odd or even. I mean, clearly f of x is not 0.
Yeah. Maybe the tan x sin x would cause it to be odd.
Excuse me?
So my only question is how do you do that f of minus x with the log? Do we have to expand it, and then I'm just trying to figure out how, because inside the log, at least we know that cos x is equal to cos minus x, and sin x is equal to sin of minus x is equal to minus of sin of x.
Yeah.
So
So what's the issue?
So does that imply directly that f of x is odd, or do we have to break down the steps a little bit more?
It does not apply. It does not show that f of x is odd. The thing is,
Yeah,
okay. Cos of minus x will become cos x, and then in sine by cos, which is in tan, there will be a minus of sine x. But then again, you do not know the structure of the function cos x minus sin x or something like that.
yeah,
Sec of x minus tan of x.
so there's some expansion that we need to do.
Yes, we need to do that, and there will be a very short interval of conflict. But when you try to solve it, it will be gone. I mean, I'll show you how to do that. It's simple. I mean, just put sorry, f of minus x. We don't know whether this is odd or even, right? So I will start with f of minus x. So because f of minus x defines the result of f of minus x defines whether it will be odd or even. So this is nothing but uh, log of sec of minus x plus one second, tan of minus x whole cube. So this whole cube is outside the log. Now then this is, yeah, somebody is saying it's not odd. Let's see. Log sec of minus x will remain sec of x. This is because cos of minus x is cos of x. And if you just put a reciprocal, it will remain the same, and reciprocal is nothing but sec of x. So this will be log of sec of x minus
Yeah, tan x
minus tan of x. A minus will come because
of sine.
yeah, the tan of x, so tan of minus x is sine of minus x by cos of minus x, right? But then cos of minus x is cos x. Sine of minus x is minus sine x. So you can just take this minus out, and what you will remain is minus of tan x. So this plus will become minus of tan x whole cube. Okay. Now, so just just observation. What is uh what is sec square x minus tan square x?
1.
This is 1, and this is nothing but sec x minus tan x into sec x plus tan x. So what I will do is, instead of sec x minus tan x, I can write it as 1 by sec of x plus tan of x. Maybe you'll see why that helps.
Oh, okay.
Yeah.
Yeah, then it's neither odd nor even.
Uh,
But
let's see.
yeah,
Let's see. Yeah. So in place of sec x minus tan x, I'll just write 1 by sec of x plus tan of x. Uh, Next page. So you have, sorry. So you have f of minus x is equals to log of 1 by sec of x plus tan of x whole cube. Now this is simple, so you can write minus of log sec of x plus tan of x. Now the result is evident, whole cube, because the thing is, I don't know how much you all know. I'm just stating every simple thing. So this is log of 1 by x is minus of log of x. So this is minus log sec of x plus tan of x whole cube will come here. But if you see, this is nothing but minus of this is f of x. So interestingly, it's you get f of minus x plus f of x equals to 0. So it's an odd function.
okay.
So the thing is, out of these two options, it's just odd.
Correct.
And
This is not even.
yeah, let's see.
Before you start one on one and on two, is it fine if you can just show like the basics of like the when we do one to one on two, right? There are certain steps you perform uh like the basic formula before you try to find out whether it's one to one or on two. If
Yeah,
uh if that
sure.
wouldn't take too much time.
Yeah, sure. Okay. So what's an O11 function? It's something like, so I'm in page 3. Okay. So one element will only map to one and only one element. So how do you write this mathematically?
So if you had an f of x1, and for that you have a range a value y1, then you cannot have f of x2 equals y1. You will basically try to prove that, right, when you're um, showing it as a one-to-one.
Yes. Okay. Uh, the thing is, every element x1 and x2 and x3 will map to only one element uh, on the codomain. It is why it is well possible that there are other elements which does not get mapped. That's not of our concern. But the thing is, one element gets mapped to the other element. So if you think, it's something like this: if two elements, so there is this uniqueness. If two elements are unique, then because it gets mapped to only one and only one element, the image of those two unique elements are also unique. So another way of saying is, if x1 is not equal to x2, then you have f of x1 is not equals to f of x2. So this is so one way of saying that it's one, but you just have to generalize it. Something like, uh, let's try. If x of I is not equals to x of j, implies x of j is not equals to x of I for all I, comma j. So let's this set be a and this be b. Then we say that this map from a to b, which I have said is f, and f is on 1 1. Okay. So another way of saying is, so this is the first way. Another way, so there's a reason why I'm saying that there are two different representations of the same thing. So this statement is a kind of a logical statement. Okay. It's a statement. It's a logical statement because it's a logical because there is an involvement of not equals to implies again not equals to. It's a logical statement. Two things are not equals to each other. This implies that the maps of those two things are not equals to each other as well. So this is a logical statement. Uh, the thing is, in logic, there is one more. There is something which you should know because it's quite helpful sometimes. The first one is not the first one. I'll just stick to this one. The statement is something like, you have a statement A, and that particular statement infers, or we say it implies, another statement B. Okay. So this is a logical statement as a whole. So this statement you can look at as this particular one. A is the statement xy is not equals to xj for all ij. This is the statement A. And the statement B might be f of xi is not equals to f of xj for all ij. Okay. This is the statement B. So this particular statement implies this particular statement from one. I'm just giving you an example. So in logic, you can prove that if a particular statement A implies another particular statement B, then this whole statement implies one second. Where was the symbol? I forgot. What's the symbol? The negation of statement A. Sorry. The negation of statement B implies the negation of statement A. Okay, it means, so what's the negation? It's something like x1 is equals to x2. The negation is x1 is not equals to x2. The color of A is here is blue. The negation of that statement is the color of A is here is not blue. That's the negation. Okay, so this is something, it's called contrapositive. The whole statement is called a contrapositive statement. It's a very important thing you should know, because sometimes it's difficult to, so you might think that in sometimes in mathematical induction or same in any kind of you might quite find that a particular statement cannot be proved. It's very hard to prove, but the negation of that statement is proof, can be easy to prove. If you prove the, so it means if you prove the negation of this, we call it a contrapositive statement. So this is the contrapositive statement. If we prove the contrapositive statement, we can say that the positive statement is true as well. So it's the same as proving A implies B. If you prove not B implies not A. So here you can simply say that sometimes it's difficult to prove f of x1 is not equals to f of xi, given xi is not equals to xi. Then in this case, it becomes sometimes easier to prove that if f of x1 is equals to f of x2 implies x1 is equals to x2. So this is the negation. So this is this one. You can see that not B, right? Not B is f of x1 equals to f of x2, or I'll just simply use I, j. F of xi is equals to f of xj. So this is the negation of this particular statement. This implies xi is equals to xj, and this is the negation of statement A, which is xi is not equals to xj. The negation will be xi is equals to. So this is an equivalent statement you can prove. It's just, I just with the help of logic, I just kind of gave you a brief interpret, because it's really important. Sometimes a tricky question might come where you won't be able to prove the first statement because of the complexity of the different hypotheses there in the question. But you just turn it into a logical statement, and you can simply show, you can, if you if you simply show the contrapositive statement, you'll be able to show that the first statement is true as well.